All right, for this next section, there are again a few things that we haven't gotten to yet, so we're going to skip them and just stay with what you need to know for right now. So we're going to look at problems 1b, 3, and 4, and then we're going to be done with this section. So in problem number 1b, what you've got now is you've got bases, like bases that are being divided. So you already know that when you multiply like bases, you're going to add the exponents. So when you divide like bases, you're going to subtract the exponents. There's also another way of doing this that might be a little bit faster for you, and it might make a little bit more sense to you as well. I'm going to go ahead and show you both ways so you can get a feeling for both of them. So what we see here is we've got m squared divided by m to the fifth, n to the fourth divided by n to the third. Again, you can break this up and look at it as two separate fractions if you need to. Really what this comes down to is we're going to go 2 minus 5 and 4 minus 3. So we've got m to the 2 minus 5 times n to the 4 minus 3. M to the 2 minus 5. 2 minus 5 is negative 3. So m to the negative third. And then n, 4 minus 3 is just 1. So we're just going to leave that as n. Now, again, we can't leave this negative exponent hanging out here. So we've got to do something with it, which means flipping the m down to the denominator. So that n is going to stay where it's at, and the m is going to become m cubed. So n over m cubed is going to be your solution. The other way to think about it would be like this. Where do I have more m's at? In this case, I've got, go ahead and erase this. You've got 2 m's in the numerator. So m times m, and then 4 n's. So n times n times n times n over m times m times m times m times m. There's 5 there, and then 4 there, and then 3 n's down here. So you can just think of it like this. I've got 3 n's here and 5 m's here, or 2 m's here, 5 m's here. There we go. What can I cancel out? I can cancel out these two with these two. So I'm left with 3 m's in the denominator. Here, I can cancel out 3 n's with these 3 n's, and I'm left with 1 n there, so I get n over m to the third. So that's the way that I tend to do it. But I just skip this entire step right here. I just think to myself, if I've got 2 m's here and 5 here, where do I have the most m's? I've got the most m's in the denominator. How many am I going to have left once I've canceled them out? I'm going to have 3. Where do I have the most n's? I have the most n's in the numerator, and I've got 4 there, 3 in the denominator, so that means I'm going to have 1 left over in the numerator, and so that gives me my n over m cubed answer. So that's the second way of looking at it, and that's the method that I prefer. I don't like having to go through adding and subtracting all of these things and then doing multiple steps to get to a solution when there's a much easier way of getting to it. You do, however, want to remember the rule or the property that's applied to it, because you may need it later on. Now with this, in problem number 3, we're given z to the 2/3 over 5, and both of those are being raised to the 3rd power. I don't normally like giving you rational exponents, but the rational exponent is going to be gone once we do our distribution. So I'm not worried about you having a fractional or a rational exponent here, because it's not going to stick around for any length of time. So again, what is the exponent on this 5? It's a 1. And then what do we do whenever we've got an exponent being raised by an exponent? We multiply them. So that means I'm going to multiply that 2/3 by 3 and that 1 by 3 as well. So z to the 2/3 to the 3rd. So the 3's cancel out and you're just left with the 2. So this becomes z squared over 5 to the 1st to the 3rd. So 1 times 3, 5 cubed. Now go ahead and simplify that 5 cubed because it's a fairly easy one to work with. And so you get z squared over 125. And that's going to be your solution for problem number 3. In problem number 4, we just do the same thing that we just did right there. There are a couple of ways of doing this one, so I'll show you both ways. The first way would be to get rid of this negative exponent first. And so that's going to be taking everything that's in this set of parentheses and flipping it. So if it's in the denominator, it goes to the numerator. If it's in the numerator, it goes to the denominator. So I'm going to go y to the fourth over 2x to the sixth raised to the third power. Remember, the negative goes away once it's done its job. Or I could just go ahead and distribute this negative 3 through to everything. Let me just go ahead and finish this one off first before I do that. So I'm going to take this 2. Remember, this 2 has an exponent of 1. And then I'm going to distribute the 3 through to everything there. So y to the fourth to the third. So 4 times 3 is 12. So y to the 12 over 2 to the first to the third is 2 to the third. X to the sixth to the third is x to the 18th. So now we got y to the 12th over 2 to the third is 8, x to the 18th. Now if I've done this correctly, I should get the same answer working it through the other way. So since I flipped this first, what I'm going to do first on this time is I'm going to go ahead and distribute this negative 3 through to everything. So remember, that's 2 to the first. 2 to the first to the negative third is 2 to the negative third. X to the sixth to the negative third is x to the negative 18th over y to the fourth to the negative third is y to the negative 12th. Okay. So bring down the 2 to the negative third and the x to the negative 18th and flip up the y to the negative 12th. So we get y to the 12th over 2 to the third x to the 18th, which simplifies to y to the 12th over 8x to the 18th. And you can see that either way we do this, we're going to come out with the same answer. And that's really the beauty of working with exponents, is you can do multiple things with, or you can work multiple processes or work multiple ways with exponents, and you can still come to the same answer. You can start off the same way and then split in the middle, and you can still come out to the same answer, simply because that's kind of the way exponents work.